So in this video, we're going to use the sum and difference rules for derivatives that we just developed in the previous video. And in fact, to do the next two slides, so I have two examples to do. To do the next two slides, we really need to put all of the things we've done over this set of videos to use. We need to use the general power rule. We're going to need to use the sum or difference rule. And we're going to need to use the constant multiple rule for taking derivatives. So the first one says find d dx of 5x cubed minus 15 over the third root of x squared. And now I want to recognize I have a difference of two functions. So if I have a difference of two functions, I can break it into the individual the derivative of the individual function. So if I want to do d dx of this difference, I can just do d dx of the individual functions. So d dx of 5x cubed minus d dx of 15 over. And I probably want to get this out of the radical form. So I want to recognize that this is the same as x to the 2/3 power. And here I have a derivative of a constant times a function. So I use this rule right here to say, hey, I'm going to get the same thing if I take 5 times the derivative of the function itself. So 5 times d dx of x cubed minus, and here I really do, I'll do this in a couple steps, but I really do have a constant. Let's erase that. A constant times a function. I do have a constant times a function. We want to recognize that. So I can break this guy up. 5 times d dx of x cubed. Hey, that's an x to the a form. Use the power rule. Bring the 3 down into the coefficient position on x and subtract 1 from the exponent. Minus the derivative of a constant times a function is 15 times, is the constant times the derivative of the function. And to get this in the form x to the a, I'm going to need to bring this x to the 2/3 up into the numerator position. So I'll need to change the sign on the exponent from positive to negative. 5 times 3 is 15x squared minus 15 times. This is in the form x to the a, so I can use the power rule, which says bring the exponent down into the coefficient position and then subtract 1 from the exponent. So negative 2/3 minus 3/3 is negative 5/3. And then I can do some simplifying here because 3 will go into 15 5 times. I get 15x squared. I get a negative times a negative is a positive. And 5 times 2 is 10x to the negative 5/3. So I have one more example. This one says take d dx of 4x cubed minus x squared plus x all over x. So a common strategy when you have a monomial in the denominator is to break it into individual fractions. So d dx of 4x cubed over x minus x squared over x plus x over x. So you break into the individual individual fractions that you get with your common denominator, and then look to see if anything can be simplified. So d dx of 4x cubed over x is going to be 4x squared as long as x is not equal to 0, minus x squared over x is just x, plus x over x is 1. So I get plus 1. So here I have the sums or differences of functions. So if I have sums or differences, I can break it into the individual pieces. So I'm going to break this up as d dx of 4x squared minus d dx of x plus d dx of 1. And now I have d dx to take the derivative of a constant times a function. Well, I can use this to say I'm going to take the constant times, sorry, the constant is 4, the constant times the derivative of the x squared of the function minus, hey, this is x to the first power, so it's in the x to the a form, so I'm going to bring the 1 down in front of the x. 1 minus 1 is 0, plus, hey, the derivative of a constant is 0 from the, I think, the first video we did for this set. 4 times, take the derivative of x squared. It's in the x to the a form, so bring the 2 down in front into the coefficient position. X to the, decrease the exponent 2 by 1. 2 minus 1 is 1. Minus 1 times x to the 0 is 1. We raise things to the 0th power. We get 1 in general. Plus 0 is not going to do anything for us. 4 times 2 is 8. X to the 1, we'll just write it as an x, and this is minus 1 times 1 is minus 1. So there's our derivative. And in general, d dx of x is always going to equal 1. So this is something to put in your pocket. I probably should have done a separate little video just for this and called it a special case. But that's what happened over here. We took d dx of x to the first, and we wound up getting a 1 out of that right here.